All right, let me do some problems, some real fundamental theorem of calculus problems. Of course, what does the fundamental theorem of calculus say? It says to us that if you have the antiderivative of little f, that's what this says. It says you have the antiderivative of little f. The antiderivative here is capital F. If you have an antiderivative, then you can find a definite integral of little f. It would just be the antiderivative evaluated at the endpoints, and you take the difference. That's the fundamental theorem of calculus. So they've got here this integral, and it's the integral from -3 to 3 of that polynomial, 3x cubed minus 2x squared plus x plus 1 dx. It integrates to, so it integrates to, let me write it like this. Then capital F of x is 3/4 x to the 4th minus 2/3 x cubed plus 1/2 x squared plus x. And we don't need the plus c in this case. So when we're doing fundamental theorem of calculus, we don't need the plus c because it would just cancel out. Then I want to find f of 3, and I want to find f of -3. I want to take their difference. F of 3, let's see, that's going to be 81 minus 18 plus 3 plus 1. That's what I get for f of 3, and then f of -3 would be a minus 81 minus 18 minus 3 plus 1. Okay. And we're going to take this minus this. So then that means that means that, I have a minus symbol out in front of all of this stuff. So all of my signs are going to change, right? These are all plus, and now this is a minus. So I can see what's going to cancel out. The minus 18 and the positive 18 will cancel. The 1 and the negative 1 will cancel. This integral is just 81 plus 3 plus 81 plus 3. So that's 2 times 84. It's 168. Oh no. They're saying minus 30. Okay, well, let me back up. So, fundamental theorem of calculus problems, where does it usually go wrong? Down here. So, let me just make sure I didn't do something dumb. Okay. So let's check this, then I'll check my antiderivative first. So 3/4 x to the 4th minus 2/3 x cubed plus 1/2 x squared plus x. That all looks good. Oh, you know what? I did goof it up. When I put in capital F of 3, I put it up here like a dummy. It doesn't go there. It goes in my antiderivative. So, sorry, I was looking at this. What I computed was f of 3. Don't do that. So, I gotta look at this one. Okay, super. So this would be 81 over 4. No, it would be bigger than that. Gosh, it would be, I'll do it like this. It would be 3/4 of 81 minus minus 2 times 9. Plus 9 over 2 plus 3. There we go. And then f of minus 3 would be 3/4 of 81 plus 18 plus 9/2 minus 3. And then it's going to be this minus this, so the sign of all of these down here would change. And now I can see what's going to cancel out. This and this would add up to 0, and this would add up to 0. So you get minus 18 plus 3 minus 18 plus 3. And so that right there is just minus 15 minus 15, and so you get minus 30. Okay, good deal. Excuse me. There is another way to handle a function that's being integrated on a symmetric interval, but it has to be what's called to do the simplification, you need an even or an odd function. And if you don't know what that is, then don't even worry about it. Just learn the one technique and be done with it. Here we have the integral from -1 to 1 of 5t cubed minus 3t squared minus 2t minus 8 dt. Okay. There we are. Then my antiderivative at t is 5/4 t to the 4th minus 3 over 3 t cubed minus t, 2 over 2 t squared minus 8t. There's my antiderivative. Then capital F of 1 would be 5/4 minus 1 minus 1 minus 8, and capital F of -1 would be 5/4 plus 1 minus 1 plus 8. Okay, and then I really want the negative of this, so all of these have to change sign. Okay, and then I can see what's going to cancel. This and this are going to cancel, and these two just add up to 0, so they're gone. So really what I have is minus 10 minus 8, so that's minus 18. And we are doing the fundamental theorem of calculus. what is the value of the definite integral? Okay, so it's from 0 to 2, and the function is 2x cubed plus 5x squared minus 2x minus 9 dx. Derivative is 2/4 x to the 4th plus 5/3 x cubed minus 2/2 x squared minus 9x. Now capital F of 2 would be 8 plus, I'll just say 5/3 times 8 minus 4 minus 18. And very conveniently, capital F of 0 is 0. Okay, so all I need to do is compute this. Okay, so the 8 and the minus 18 give us minus 10. Minus 10 minus 4 is a minus 14. So this is just minus 14 plus 40/3. But I want this minus 14 to look like something over 3. So I'll go like that. And then you have minus 48/3 plus 40/3. Answer minus 8/3. And wouldn't you know, there's another problem here. They get minus 2/3. So let me back up. What did I goof up here? 3 times 14 is not 48, it's 42. That's the problem. So most of the times what's going to happen is you're going to have a problem with your arithmetic. This is minus 42. And then that makes this be minus 2/3. Super. %38 mastery. Okay. Here we have another definite integral. It is from minus 3 to minus 1 of the function t cubed plus 6t squared plus 9t plus 9 dt. My capital F of t would be 1/4 t to the 4th plus 6/3 t cubed plus 9/2 t squared plus 9t. Okay. Capital F of negative 1 is going to be 1/4 minus 2 plus 9/2 minus 9. Capital F of negative 3 is going to be we'll say 81/4 minus 2 times 27. That's 54. Plus 81, no, yes, plus 81/2, and then minus 3 times 9 minus 27. All right, we need to take this minus this. I'm not going to get any of that fancy cancellation like I liked because this is not a symmetric interval. So I will just, I guess, compute this one and compute this one and take their difference. Okay, so we have 1/4 plus 18/4. That's 19/4 minus 11. So it's 19/4 minus 44/4. You get minus 25 over 4. And then down here we get 81 over 4 plus 162 over 4 is 243 over 4. And then minus 54 minus 27 is a minus 81. And then, so that's 243 over 4 minus 324 over 4. This comes out to minus 81 over 4, if I did that right. So this should be (56 over 4), if I did that right. And 56 over 4 reduces to just 14, and yeah, that's right. All right, let's see what the other objective is. Oh, it's just doing it with a substitution. Okay, so here you have the integral from -1 to 0, and it's that integral. So from -1 up to 0 of minus 5x times 3x squared minus 2 quantity cubed. You need to let u be 3x squared minus 2. Then du is 6x dx. I don't have a 6x dx, I have a minus 5x dx. You can easily fix that, just multiply on both sides by minus 5 over 6. Then over here the 6's cancel, and we are left with minus 5/6 du being minus 5x dx. So keep in mind that these numbers here are x values. You cannot put them here and here when you do your substitution. Right? So we're getting minus 5/6 du. That's what the minus 5x dx is. And then this part in here is just u cubed. And I want to put my new limits of integration here. They need to be u values. Right? How do you get them? You just take these limits and put them in your substitution, and it will compute the u. So when x is -1, we get just 3 minus 2. that's 1. So this lower limit is 1. And when x is 0, we get u equals to -2. So these are my limits of integration from 1 up to -2. Now it feels weird saying from 1 up to -2, so you can always switch this around, because you know we have the property that if we have the property that you can invert those limits like that by just putting the negative out front. That's really easy to show why that's true. And my integral already has that negative because of the negative 5/6, so I will just say 5/6 integral u cubed from -2 to 1 du. Then my 5/6 just kind of hangs out, and then here's a lot of people will write it like this, right? So they've done their antiderivative, you know, this is my capital F, and then and instead of doing it like I was a minute ago, which is nice and clean and perfectly fine with the capital F and everything, people will just say you know, the top one minus the bottom one. So you put the 1 in for u and you just get 1/4. You put the -2 in for u and you get 16/4. And so whatever this computes to be is our solution. I should have just left it as 16/4. That was actually more convenient for me. So the number in the brackets is a -15/4. So we have 5/6 times a -15/4, and I'll cancel a 3 here and here. Then this is -25/8. Let's see if I'm right. Hot dog. -25/8. Alright, I'm going to do one more, and then I'm giving up. You're going to have to do the rest of them. I got too much stuff I need to do. This one looks easy. Let's just not and say we did. I mean, that one's easy too. That one's especially easy because you got your limits of 1 and 0. Well, I guess we'll do this one. Alright, so it's the integral from 0 to 1 minus 3x times the quantity -2x squared minus 1 to the power -3 dx. Let u be the -2x squared minus 1, then du is -4x dx. I don't have a -4x dx, I have a -3x dx. You can easily remedy this by just multiplying on both sides by 3/4. Because then these 4's cancel and you have that 3/4 du is a -3x dx. Okay. Then what are my new limits of integration? Take the 0, put it here for x, and you just get -1. Take the 1 and put it here for x, and you get -3. And when I do my substitution, this would be 3/4 du, and it's u cubed. Okay? So that antiderivative would be, capital F of u would be 3/16 u to the fourth. And we're going to have to compute capital F of minus 3 minus capital F of negative 1. But capital F of negative 3 would be negative 81 over 4, and capital F of negative 1 would just be negative, so that minus symbol is this one, right? And then right here will be capital F of negative 1, but that's negative 3/4. So we get negative 81 plus 3, so I'm getting negative 78 over 4, which should reduce, because they're both even, to negative 39 over 2. And I've done something wrong. They're saying it's 15. How much you want to bet that my mistake is in my arithmetic? Let's see. So this is a good antiderivative. Check my limits of integration. So you put the 1 right there. It says minus 2 minus 1. Okay, so this is all good. And when I put a minus 3, oh, I did it again. I used this function to compute these numbers. Do that. I'm sure you guys are wondering, like, where is he getting these numbers from? I don't understand. Well, it's because I'm not doing it right. So maybe that's a good argument for doing it like this, and just saying, well, saying, well, this is my 3/4 will come out, and then we have our 1/4 u to the fourth evaluated between minus 3 and minus 1. You could simplify that even further and just say 3/16, and then here's my u to the fourth minus 3 minus 1, so this would be 3/16. And then a minus 3 to the fourth is 81. And a minus 1 to the fourth is just 1. So that's 3/16 of 80. And yeah. You just get 15, like they did.